So the main objective of this conference is to speak a little bit about what is artificial intelligence and how can we apply it to the business. So he's very knowledgeable on this subject. So I'll give space to Kamil to start speaking. Okay, go ahead, Kamil. Thank you.
Yeah, thank you, Juan Jose. So I assume, gentlemen, that you have some kind of expectations toward what you would like to hear, but I will try to start with like general introduction, so we have more or less the same page of understanding of the subject, and then please just fire away with any questions you may have, and I will be happy to answer. Okay. So as Juan Jose mentioned in the beginning, I have PhD in computer science, and specifically speaking in data mining, which is like a subset of data management theory in computer science, also covering data science. Okay, and data science is all the statistical techniques that you apply in computer science for implementing artificial intelligence. And this concept of artificial intelligence, we may very often see that like the Terminator movie, or kind of, you know, weird robots doing different things, but it's actually much simpler when you think about what's that in per se. So this is not a new concept, to be honest. In computer science theory, artificial intelligence was invented around 1970s, 1960s even. There was huge contribution from the University of Toronto researchers into that. So they actually invented the algorithms that we use right now for artificial intelligence back then in 1970s. The problem was there was not enough data, and computing power was very expensive at that time. So similarly to many other theories, like in physics, you had the Higgs particle, yeah, the Higgs boson, that was theoretically there in the model, but it was proven to be there empirically just recently by the Hadron Collider in Swiss. So the same happened with AI, and artificial intelligence in its principle, it's based on one very important assumption. So when you think about software, and it can be any type of software, okay, from the Excel sheet or ERP system that you use towards the camera application on your iPhone, it can be any software. It can follow one of two principles. The first principle is, let's assume that you are a creator of a software, yeah, and you say, okay, so I know what my software is supposed to do. It should take the input data, do this algorithm, and then provide me the output. Yeah. So that's the traditional software creation process. In AI, it's actually a bit different. So what you do is you say, okay, I have my input data. I have no idea what's the algorithm here, but I know what I want to have on the output. Okay. And then you tell the computer, do the calculations, invent the algorithm for me, which converts this data into this output. Okay. And as long as your input data is representative, and the computer has enough computing power, of course, then you can create an algorithm that is basically describing the phenomena you'd like to conquer. It can be forecasting, it can be image recognition, like face recognition. It can be voice recognition. All of those cognitive functions that we very often talk about when we think about AI. One funny thing about AI, there is this paradox of Moravec, the Croatian researcher, that, you know, for us humans, it's very common to think that those cognitively difficult things like playing chess, doing coding, doing some other, let's say, statistical or scientific exercises, it's hard. It requires from us a lot of focus, a lot of input of our like willpower. But for the computers, it's easy. On the other hand, it's super hard for the computers to imitate how people walk, how people grab items, how people recognize the voice of let's say, parents, for example. You have like 2-year-old and he perfectly understands that that's his father voice, that's his mother voice. It's super hard for the computers. And that's probably because our brains, they are so long in this process of like, developing new neural collections for many centuries. We developed this system of connections in our brain, which is basically very powerful for cognitive functions. In the same time, it doesn't require too much willpower from us to understand who is actually speaking, to recognize the voice. For the computer, it's super hard. It's super hard because the computers are very good in understanding numbers, understanding things which for us are hard to do because it requires computational power. That's the skill that humans have like for maybe 200, 500 years. Yeah. So it's nothing compared with the centuries of evolution of human brain that gives us this, let's say, cognitive function masterclass compared to those technical things. So when you think about AI specifically, it's very often hard to say what's this precisely, because that's a subset of different statistical techniques and different programming techniques that you can use. But in general, the idea is that, okay, you have the input data, you have the output data, and you would like to understand what's the algorithm that gives you the prediction. So it's usually a regression problem from a statistical standpoint or classification problem. For example, you may have a photo of something, like you would like to classify your photographs in 2 types. Is this photo made outside or inside? Okay, for a human, very simple task. You take a look and okay, that's inside the building. You take a second one, that's outside the building. But how can you actually teach the computer to recognize that? That's something really hard, right? What are the features that define outside, inside? There are some kind of abstract things, yeah, for the computer. The same happens with AI. Whatever thing we would like to model with AI, we need to find those features that define this object, this phenomenon, this actual problem. So in case of our solutions, what we provide to our customers, the problem that we solve is the forecasting, right? Based on the history, on the data that we have, and on what we want to achieve. For example, we want to increase sales. We want to reduce out of stocks and overstocks, okay? So we take the data that we have from history, the data of your orders, the data of your customer communications, the weather data, whatever is influencing sales in our ecosystem. We take this data, and because it's certain, how much pieces you sold to each customer in the last years, right? That's fiscal data, so it must be very precise and sincere. So you take this data and you divide this data in 2 parts. One data is used as training set. Second part of the data is used as test set. So what you do is you put this into the model, and the model is the implementation, the software implementation of those statistical techniques invented in 1970s, like neural networks, gradient boosting machines, many other geeky stuff that people teach on the universities. But that's primarily like, it's statistics, basically. You take the statistical engine, you put your data inside, and you verify what's actually important. So the whole exercise is just to check if in this input data, there are factors which allow you to predict the output, okay? So if your data set, if your input data is, let's say, representative, then you create a model which is a set of statistical implementation of the concepts, plus the data, let's say, the knowledge about the phenomena you would like to implement. And then the model is trained. If the model is already trained, it can possess the knowledge about the history. So that's something very powerful, which we can't do as humans, okay? Let's say you have the access to your database of your sales. Even if you read it and memorize it, 100%, you will not be able to predict what will happen tomorrow, right? Because we don't have this computational power in our brains. That's the Moravec paradox. But the computer can do it. So the computer can possess all the information and build the knowledge about what happened in the past, what was the influencing factors of what happened, and then can generalize about the future. So if we have these factors for the future, what will be the output? How much will be the sales tomorrow if I have this weather, this price, this amount of customers, this number of stores, and so on. So that's AI in a nutshell, I would say.
Kamil, could you go a little bit deeper into this concept that you told me last time, that the machine is able to identify which variables weight more in, let's say, in the end result, and this is how you pick actually the model, and how the model is every time training again and learning again and so on, because this is the difference between typical statistics and the power of AI, and this is truly important, I think, to be explained.
Yeah, so if you will now take this model that I described, okay, and if you will create one model per each item in your assortment, in your inventory, okay, and if you will create each model per each item and each warehouse, and you will follow this, let's say, level of granularity deeper and deeper, you will find yourself in a situation when you have like thousands of models, right? Each one possessing the knowledge about the historical sales of a specific product in a specific store or specific warehouse. And then this model is very powerful about predicting the future about this specific combination of store and warehouse, okay? So if you will give the task for this model to predict something different, like different product, it will not be able to do it. There is no knowledge in this model about the other things, but there is very precise knowledge about that. And what Javier is talking about is what's the difference between all of those models? First, they are trained on different data sets. They are trained on data which is specific to a given combination of product and store. But also, even if the method, let's say the statistical algorithm is the same, the factors which influence sales for different products in different warehouses can be different, right? And that's something which we as humans cannot do at all. It's like, if you can imagine how many factors are relevant for sales of your products, and now try to imagine that you can, to the degree of singular product in singular warehouse, say, okay, so for this product in this warehouse, these five factors are the most important, and for this one, those five, okay? But you have thousands of models or millions, yeah. So it's not possible for a human to do it, even if you have like army of planners. It's not possible to do it cognitively, but also time-wise, it's not possible.
Exactly.
So, and now imagine that you have those thousands of models with all of those different factors and their, let's say that's called journey index. You can check that if you wish. It's the significance of those factors for a given set of SKU in a warehouse. Okay, so those models will have this data, the information about this, and the weights of those factors. But to make it even more complicated, now imagine that you are training those models like every month. So they are updating their knowledge every month, all of them, thousands of models on thousands of different factors on different weights. But every month they get updated with the last historical portion of data that you have in your system. So that's the power of AI. Actually, that's the power of those algorithms, because they can automatically harness all the information which is in your data and use it in a productive way with a measurable quality and accuracy on a super granular level, which will be never possible to achieve by a human. Okay. And now I say that it's never going to be achieved by a human, but it doesn't mean that human is not needed, of course, because the AI is only as good as the model itself. So let's say the statistical engine that you use, because they are different, and you can mix them, you can combine them, make them more computationally greedy or less, and more costly or less, more accurate and less. But also, and the most important thing, the AI will not be able to predict things, specifically forecast sales, if the set of factors which determine the future, like tomorrow, is not in the historical data. So if tomorrow, the tomorrow's sales is going to be affected by something which was never happening in the past, the AI will not predict that, right? So that's why AI is not able to predict stocks that well, let's say. It's not able to predict who will win the elections. It will not tell you how many pieces of goods your competitor will sell, because you don't have the information about that in your data, right? So no matter how clever your model will be, if there is no pattern that it can detect in your historical data, you will not be able to do it, to use it for the future. That's something specifically important when we think about which data we use to forecast sales, because that's the question that we get from our clients very often. Like, why won't you use the information about the promotions of our competitors? Well, first, it's hard to gather them in one place with given veracity. But second, we will never get them for the future. Like, how should I know what will be the promotion in my competitor's store tomorrow? They will not reveal that information, right? So we can't actually use this feature for forecasting because we will never know that value for tomorrow, right?
Yeah, you can adjust your supply chain for a certain period of time, but you cannot predict the promotion of your competitors, right?
Yeah, absolutely. So, and of course, there are different factors that we consider more or less important for the whole process. But just to give you the overview, the degree of complexity that we can have in the models, it allows us to forecast daily per product per store, for example, monthly per product per warehouse, or even in the long term, like for the whole market. Okay, the bigger, it's like the helicopter view. If you go to your helicopter and you go very close to the ground, you can see just those 5 square meters underneath you. If you go a bit higher, then you can see the whole city. If you go even higher, you can see like the whole district. And so you can then make more general decisions or have a more general view.
I have a few questions for you. First of all, will the AI be able to define which model of all of the models, I think, like the tool we have available, like the system could define which model will be the best for a certain item or a group of items and certain locations? Is that possible with AI?
Yes, that's what we do actually in our software. So the system is choosing from the plethora of different statistical mechanisms, the one which applies best for a given SKU and store or warehouse. Okay.
Yeah.
Okay, so that will be changing in the time. Like, can we say like, right now we're doing like, I don't know, linear regression, and then tomorrow we'll do it, I don't know, weighted average, something really simple, and then the model says after this we will have to do something different, right? Will the model have the power to do that and change the model for a certain location and item after a certain period of time, because it thinks that the forecast is going to give out as an output will be better than the model we had before?
Yes, it's actually even more complex than that, because in your example, you choose between several models and you change the method completely. In our software, we have a blend of different models. So what we have is we take different statistical approaches, we calculate many of them, and then we choose a weighted average of the result. So it's more powerful because we don't change like one method to another. We constantly adjust the level of accuracy that they give back to us, and we trust this a little bit more, this a little bit less, and we find a balance between those results to be able to actually create a best model, not choose the best method, because that's different thing, right? That's very important, especially for data sets with a short history of sales, okay? Because it's very easy to create a model from a short history, but it will be very inaccurate because there is not enough data, right?
Yep.
And there are certain statistical methods that we can use, and some of them, they are more prone to what we call overtraining. So the model can possess all the data about the history, even if it's very short, but then it will not be able to generalize at all. It will be like, okay, in the history, this product was sold only like 10 pieces or 5 pieces. There is no way this model will tell you that will be other sales number than 10 or 5 tomorrow, which is not true most likely, right?
Yeah. But the beauty of this, Domingo, is that you are not even aware that the different method or a different way of calculation, because the software will deliver to you the most accurate outcome, you know? So for you, it's transparent.
Yeah. So I think what the model will be doing will be like weighting different outputs and saying, okay, so this is the level of accuracy we're getting with this is the level of accuracy we're getting with this other model. Okay, nice.
And that's actually happening when you train the model. So it's not happening every day, because that would be very inconsistent and hard to explain. But when you train the model, there is this method of, you know, taking your input data and dividing that into two parts. The first part is for training, second is for testing. And what we use is called cross-validation. So we do this division 3 times for every single model for every store and item. Okay, we divide this data in 3 ways with every single training every month. So we precisely know what is the quality of the model directly after training. We don't need to wait for the model to be actually executing every day with the forecasts. We know it already upfront if the model will be accurate or not. Okay, and then having this knowledge, we choose the best weighted, let's say, weighted blend of those statistical methods. So the accuracy that we provide is going to be highest possible with the least overtraining possible in the model.
What happens if you change some factors in the middle of training?
So we usually have like a certain number of factors which are in the input data, and the model is choosing them automatically. So it might happen that for a certain period of the year, let's say, the model will completely disregard weather. That's the case. I can give you an example that you can relate to, because you are all customers of grocery stores. So if you will go to a grocery, we are in different parts of the world, and the temperature is different. But for example, you can imagine that when it's hot, you buy more water, right? But actually, it's trivial. It's cliche, but if you think about, okay, what's the temperature threshold where people start buying more water? Is it like 20 degrees or 10 degrees or 5? That's something that the model will find automatically in the data set. Okay.
Exactly.
So I can give you a precise explanation of that. So people in Poland, where we live, it doesn't make any difference for sales of water if the temperature goes from 0 to 5, 5 to 10 degrees, 10 to 15, 15 to 20. It doesn't change the sales of the water at all. But if the temperature goes from 25 to 30, there is 800% more water sold. Okay, which is a big problem logistically, because water is very cheap product, so the margin is very low. It's big for transportation. It takes a lot of space in the warehouses. It takes up a lot of space in the trucks. So without this knowledge, and you know, this is something that the model can detect automatically. Without this knowledge about this one specific variable, you can't really optimize the workload on the warehouse. You will never have enough water during the hot days. But this threshold, it's cognitively impossible for any human to find, right? And what's interesting, that's only one variable. We have like
exactly. And one item.
We have one item, one variable, yeah. But this threshold of temperature is different for ice cream, for example. Okay. For other products like, I don't know, bread, the temperature doesn't matter at all. So the model will disregard temperature completely. It will not. It will never use it. Okay, during training. So during training, it will say, okay, it doesn't make sense, or it's auto-correlated with some other variables. Let's disregard that. Let's not make our forecasting more complex, so we don't use this variable, even if it's in the input data.
Yeah, actually what Sebastian was saying or was concerned about is about like what happens when we don't have the proper service level from our suppliers, right? How do we put that into the equation, and how do you guys solve problems like that? Because right now with the pandemic, we have been facing some really serious service level drops from our suppliers. So like we do our thing right now. Like we cover ourselves in some ways. But how will the?
If I may,
Yeah.
let me say something, and correct me if I'm wrong, Kamil. But what I can tell you is that by using the tool, you will save a lot of time of processing. You know what I'm saying? So, because Kamil was saying, you can make these kind of assumptions when you do the parameters for the replenishment part of the system. So if I were you and I get all this power for processing the data and making the forecast, I would make a trade-off in my time. Instead of putting the time into calculating the forecast, but to be very aware of what is happening with my customer and then change the strategy in the replenishment. And this is actually, I believe, the kind of work that it's going to be required. Because
that's a planner. That's a planner.
Exactly. Yeah. Exactly. So I believe that, because I've done in the past forecasting, and it's sometimes it's a shitty work because you need to spend a lot of time reviewing all these variables and going back and forth and do changes and assumptions. And when you're ready, and that's like 24 hours job, turns out that you're just starting to make the decisions. And with the tool, when you actually get to your workstation, you start working on the meaningful stuff, which is making decisions. And I believe this is where the value relies. So I don't know, Kamil, if you think the same, but I believe this is the kind of thing that we should be changing now.
Yeah, absolutely. So AI will not solve all of the problems of the world,
exactly.
But it's definitely good in liberating the time that you can then devote to those most important problems, right? It's the Pareto rule. Most likely you need like 80% of the focus on the 20% of the most important items, and not the other way around, right? And so the tool will take care about those 80% of the things that behave more or less the same. And then you, as an expert of your business, you can take care about this 20%, which is very often like making 80% of the hassle of it.
Yeah, sure.
Yeah.
Well,
no, and if I may add something, to have the capacity of having that that forecast that you can share with your suppliers, that will give them an advantage. That will give you an advantage to make sure you secure that supply, right? Because you give them that information before and with a very good accuracy. That's another thing that can make a difference.
Yeah, you will have all the tools to pressure them, telling them,
exactly.
I gave you this forecast like 6 months ago.
And
exactly.
If your competitor does not have the tool, so he will be delayed or less accurate, and then your supplier will say, okay, these guys are doing a better job. They're selling more because actually this is what will happen. And you'll be able to leverage your relationship with suppliers.
Yeah.
And another thing, I want to ask Kamil something. What is the competitive edge that this AI gives you when you have 60,000 SKUs, active SKUs, Kamil?
Oh, you can imagine that straight away when you try to put that in the Excel sheet and do the forecast manually, right? Like Excel sheet is limited to 62,000 rows, so you will not be able to do much with that. Not even mentioning that we are forecasting. We can do the forecasting every day if you wish. That will be of course more expensive, and it doesn't make sense in every business. But try to do it as a human, like 60,000 SKUs every day. It's not possible. It's not possible, right? But even forecasting weekly or monthly with 60,000 SKUs, you will need like army of people to do it.
Actually, let's say, if we're talking about SKUs as a combination of items stores, we have plenty more because we have many
absolutely.
locations. So yeah, we do have an army right now doing those calculations. Not really doing like the planning things that we would love them to do, but just doing calculations like machines.
Exactly.
Yeah, and they will still need to do some calculations, of course. As I said, it's like I consider this AI thing in our system like the autopilot for a plane. Okay, it doesn't mean that you don't need to have a pilot in the plane when it's autopilot, right? You still need to have this person which is very conscientious about the business and can supervise the process, and will interact in the most, let's say, unpredictable circumstances. Like if there is something happening very rapidly and you would like to interfere with something which is important for your business, you then step in as a person and you can apply those correction factors. You can change the business rules in the system. You can recreate the orders if you wish. You can retrain the models because something important happened. So many of those things that define your competitive advantage over the competitors who are not able to react that fast, that will be very visible if you harness the AI for the most, let's say, repeatable parts of the process.